Hey dears, welcome to this part 3 of complete DSA series. Today we are going to continue to the last video, that part 2, what we have discussed about efficiency and complexity. It's Today we are going to discuss about the asymptotic complexity. What is asymptotic complexity and how does it work? We will discuss about this. It's only theory part, so practical part I will discuss in next video. So in this video just only theory or means definition part I will discuss. So let's start. Asymptotic complexity is a powerful tool for analyzing the performance of algorithms, prove the existence of algorithms, and classify problems according to their difficulty. By ignoring constant factors, it can be used to compare the performance of algorithm on a large input, because algorithms can vary significantly depending on input size. Means as if you give the more inputs. For an example, we can say an algorithm that takes 100 milliseconds to solve our problems on an input of size 100, input size is 100, may take 1000 millions to solve the problem. Same problems to input the size of 1000. Asymptotic complexity is expressed using the big O and big omega, big theta notations. There are these three different notations. Let's these three different notations also I will discuss with practically with the calculations, but right now we will just definitions based will go. So big O notations is represents upper bound of the growth rate of functions. When we say an algorithm has time complexity of big O functions, which indicates that running time will not exceed more than that particular functions, because this is the upper bounds, means the highest worst case also we can say for significantly large input size, as if you increase the size of up to the constant factors. Example, if an algorithm has a time complexity of like big O n squares, it means the running time grows no faster than the quadratic functions. This square also read as quadratic functions. Now big omega notation represents the lower bound, means the best case of the growth rate of the functions. When we say an algorithm has a time complexity of big O growth n, means the running time will be at least gn for a sufficiently large input size, at least. Okay, so we can say that so up to the constant factors. For an example, if an algorithm has to complexity of big omega n, it means the running time grows at least linearly. So now next is the big theta notations. Big theta notation represents through the upper and lower bounds, means average bounds of the growth rate of functions. When we say an algorithm has a time complexity of theta or theta n, it means that the algorithm's running time will be bounded both above and then below, means upper and lowers, for the sufficiently large input size up to the constant factor. For an example, we can say if an algorithm has a time complexity of theta n, it means the running times grows linearly, means average. So in this way we can conclude that asymptotic complexity helps us compare and analyze algorithm based on their scalability and efficiency, allowing us to choose the most suitable algorithms for given problems before writing the programs. However, it's important to know that as asymptotic complexity does not provide an exact measure of the actual running time or memory used by the algorithms for a specific input size, but it focuses on the growth rate as input size increase towards infinity. So let's talk about the key aspects of the algorithm analysis. So key aspects means why it is important algorithm is analyzed. Okay, so let's for the time complexity, no doubt we are talking about. So before analyzing, I will talk about some important like two methods of analyzing, why we should analyze, and the priori analyze and posterior analyze, that I will talk. But before, let's key aspects means to analyze the time complexity, so that we can go with the means big O notations, omega notations. We will try to find the omega notations so that we can go with the better or best. And space complexity, we are not analyzing here about the greedy algorithms. We are talking about the dynamic algorithms. I will talk in next video, in next time, about the greedy algorithms as well as dynamic algorithms. So let's let's focus on now. We are talking average types of algorithms, means dynamic overall. So space complexity, to analyze the space complexity or maybe time complexity, and that also helps us to find the worst case, best case, and average case. Average case denoted by this big theta, and best case big omega, and worst case is big O. So now comparisons, and for trade-off also we use the algorithm analysis as well as algorithm paradigms. For algorithmic paradigms, means it also we can say that means paradigm helps to find out the strength and weaknesses of the particular algorithms. So it's dynamic programming. Okay, so how we can go with this? So it's a dynamic and greedy programming. I will talk in next more about detail. So let's talk about the efficiency of data structures. What could be the efficiency of data structures? Generally it is measured in the time and space, time complexity as well as space complexity. Nowadays we don't focus on the space complexity because there are advanced types of hardware also we are provided by the manufacturing company, so that there is no problem in hardware. Because let's even I will talk about this all in like types of analysis, so in next slides. So let's talk about just about the terms of time and space data structures. So an ideal data structures could be one of that takes least possible time for all operations and consumes at least least memory space as well as. On what basis we would compare the time complexity of the data structures? Obviously that's as a input, numbers of input based on array or based on linked list. So we are going to compare with array. Okay, and here like suppose we are given array has a fixed size, so that here I'm going to talk about, suppose we have array and its size is five numbers or 5 different data. Okay, so where we can store, and if you want to insert at the top at the first, then we must shift this other what is already stored in that array, that will be to the right, that will be shifted to the right, so that we can be able to insert like this. Suppose if you want to insert this 1 at the top at the first, then other should be shifted to the right side. So in this way, linked list also we can say. Linked list, we are going to compare one array and another is linked list, which takes least time and space as well as. So we'll talk about this. So suppose when we have the linked list here, suppose one, and linked with this linked list we will discuss in a next video clearly about. So I'm not going to discuss here about this value and then next linked list address with the complete, it comes with the nodes. This all nodes we will talk in next video. So here again I want to insert this 5 at the first. before 1 at the first, then we don't need to shift this all like 1 2 7. This will not be shifted to the right. You can directly adjust wherever. Okay, so this is, so here we don't need to shift, and it does not take time. But a linked list is take more space because we have extra space for the address. See, these are the pointer, so these are pointing to the next address. So in this way we can find. Okay, so let's conclude with this. So I can say that inserting any elements at the beginning of the list is the way faster in the linked list. Just I showed you before, we don't need to shift to the right, we can directly adjust. In this way we can compare the structures, and this will ultimately give the idea to select the best possible structures or algorithm for the particular structures for different operations. Following are the parameters which can be considered while analyzing the algorithms, like time and space basically, and some more like network bandwidth is there, register, battery power, that all also includes. So types of analysis, I talk about these types of analysis. This is really important, so you have to understand this. For an example, let's we have two different types of algorithm analysis. First is experimental, or it's also called posterior or posterior, or also it is known as the relative analysis. This analysis is analyzed after the executions of the program, so that it can say that experimental. For an example, let's suppose I have 5-line code program. If I will execute that program, suppose let's think it takes 5 seconds to execute that program in my normal CPU. If I will increase the hardware, means i7 i5, then maybe it takes 1 second to execute that codes. Okay, so so we can say it depend on the hardware as well. Hardware space increased, so we can say that it's based on the space. And now another we have Priory, or it's also called independent or absolute analysis. So in this analysis also we can say that analysis before the execution, before writing the codes. Okay, if we are going to analyze the hardware, so we are going to focus here for the algorithms Priory or independence or absolute analysis. So this Priory analysis is for best for the algorithms to analyze before coding. Okay, so like we can say that we do analysis using the asymptotic notations and mathematical tools. So asymptotic is a kinds of mathematical tools, also we can say only that algorithms that is before converting it into the programs of a particular language. So it is determinations of the order magnitudes of all statements, also we can say, or we can say the iterations or loop. Frequently how many times it's looping, how many times it's executing, that is based on. So as finally we can conclude with the asymptotic analysis. We evaluate the performance of algorithm in the terms of input size. We do not measure the actual running times, we calculate. So how does it time or space taken by the algorithm increase with the in size of the data, input size also we can say. So and these are really important, so you should go. And now in reality, in next video I'm going to talk with the practically with example asymptotic analysis, how we are going to use this asymptotic analysis, how this asymptotic analysis is and helps in analyzing with the different calculations. Okay, that with the notations, with all different notations I told you, like a big O and omega, big omega and big theta and small theta, small omega, that also we will talk about this all. So with the calculations like this, we will calculate with all quadratic and exponentials as well as constant. So in next videos so I wish to see you in next video. So thank you this much for today.